Picture an asteroid. You're probably imagining a potato, one lump of rock tumbling through the dark. Now imagine three lumps joined at the neck like a cosmic string of pearls, and a tiny moon keeping pace alongside.
That's a real object, out in the main belt. And until this week, nobody knew it looked like that. We'll take you there first.
And then we'll chase a wind, one that lights up our own sky, and the same kind of wind that's slowly stripping a planet bare.
G'day, and welcome to Astronomy Daily. It's Friday, the 31st of July, 2026. I'm Avery.
And I'm Anna. 4 stories today, a Skywatch that spans both hemispheres, and a thread running right through the back half of the show. Avery, where do we start?
Where else? With the three-faced asteroid.
So, asteroid 44 Nysa. The number tells you it was one of the early finds, discovered back in 1857. One of the brightest asteroids in the whole main belt, that broad river of rubble between Mars and Jupiter. It's about 75 kilometers across at its widest, so a serious chunk of rock. One of the largest of its particular type. Its type matters here. Nysa is what astronomers call an E-type. Its surface is rich in a pale mineral called enstatite, which makes it unusually bright and reflective. There aren't many big E-types, so Nysa has always been a bit of a favorite. But its shape has been a nagging mystery for years. Earlier observations hinted it might be what's called a contact-trinary, 2 lobes stuck together, a bit like a peanut or a snowman. We've seen plenty of those. Comet 67P that Rosetta visited, the little asteroid Dimorphos that the NASA DART mission crashed into last year, Donald Johanson that the Lucy spacecraft flew past last year. 2 lobes is almost normal. Nysa isn't normal. A team led by Kate Minker at Lowell Observatory has just announced in a study with the wonderful title Unmasking 44 Nysa that Nysa appears to have 3 lobes, 3, joined by 2 narrow necks, like a figure carved with 2 deep waists around it. If it holds up, it's the first tri-lobed asteroid ever seen.
3 lobes? How do you even see that? These things are tiny dots, even in big telescopes.
That's the clever part. They used 2 of the sharpest eyes on Earth. The Large Binocular Telescope in Arizona, its main mirror is about 8 meters, roughly 3 times the size of Hubble's, running an instrument called SHARC-VIS, plus the very large telescope down in Chile. And they used adaptive optics, a mirror that flexes hundreds of times a second, nearly 600 tiny actuators pushing on it to cancel out the blurring of our atmosphere in real time. The result is sharper than Hubble. They imaged Nysa on 2 nights, the 15th of February and the 21st of March this year, and both times the same strange 3-part silhouette turned up. Which brings us to the second surprise. Nysa has a moon, a little one, about 1 kilometer across, orbiting at least 170 kilometers out. It's been given the placeholder name S/2026-441, and it was hiding in plain sight, drowned out by the glare of the much brighter asteroid next to it. To dig it out, the team borrowed a trick from a completely different corner of astronomy. High-contrast imaging, the same family of techniques we use to pull a faint planet out of the glare of its star. As one of the SHARC-VIS scientists, Gianluca Licausi, put it, they used that technique to catch a faint companion whose light was being swamped by the primary. And because they caught it moving across 2 separate observing runs, they know it's genuinely in orbit, not a background star photobombing the shot.
And a moon is useful, right? Not just a bonus?
It's enormously useful. This is the thing I love about it. Watch how fast the moon goes round and how far out it sits. And you can weigh the asteroid. You get Nysa's mass. Combine the mass with the size and you get its density. And density is the whole ballgame here, because there are two competing stories for what Nysa actually is. Story one, it's a genuine three-part body, maybe a contact-trinary, three chunks that drifted together and gently stuck. Story two, it's one solid, deeply dented lump that only looks three-lobed from our angle. Density can help tell those apart. A loose rubble pile reads light and fluffy. A solid, coherent rock reads dense. So that little moon is going to help settle what kind of world this is and how it got so weird.
Any theories on the how?
Nothing locked in, and that honesty is the fun of it. It could be a record of gentle, slow motion collisions in the belt, bodies bumping and merging over billions of years. It could be the aftermath of a bigger smash that left a battered survivor. Or observations of that moon will narrow it down. For now, we've got a brand new kind of object, a triple-lobed asteroid with its own satellite, sitting in a part of the sky we thought we understood. And that's the quiet lesson of Nysa. It was found in 1857. It's one of the best studied bright asteroids we have, and in 2026, it still had two secrets left, a shape nobody expected and a moon nobody had seen. The solar system is not done surprising us.
From a world we can nearly touch to one we may never reach, but might one day actually see. NASA has just backed a genuinely audacious idea, a plan to photograph the surface of a planet around another star. Not detect it, not measure it, see it. Continents, oceans, weather.
Hang on, we can't do that? I feel like we have pictures of exoplanets.
We have dots. Every exoplanet we've ever found is in a sense invisible. We infer it from a star's tiny wobble or a faint dip in brightness as the planet crosses in front. In the very best cases, we've captured a single pixel of light. Nobody has ever resolved a surface. The problem is brutal. A star can be around 10 billion times brighter than the little Earth-sized planet beside it, and the two sit almost on top of each other in the sky. The new concept comes from physicist Paul Stankus at Brookhaven, and it's one of 18 early-stage ideas NASA just funded through its Innovative Advanced Concepts Program, NIAC. These are seed grants, small money, 9 months, permission to chase something wild. His is called Mapping Alien Continents. It works in 2 moves. First, a new kind of light-canceling instrument, a nuller, that blots out the star's glare while keeping the planet's light at a contrast of 10 billion to 1 or better. Then the really bold bit. You fly 2 of these on separate spacecraft about 100 kilometers apart and combine their beams so they act as one enormous telescope, big enough in principle to resolve features on the planet's face.
A telescope 100 kilometers wide made of 2 spacecraft flying in formation.
That's a dream, and I want to be honest about where this sits. It's a concept study, not a mission on a launch pad. It may never fly in this form, but this is exactly how the big leaps begin. Someone asks, what if we could actually look? And NASA hands them a little funding to find out whether the physics holds. If it ever came together, it would turn exoplanets from statistics into places. Now, Anna, speaking of things we can see from right here,
we've got weather coming in, space weather. Forecasters at NOAA are tracking a couple of clouds of solar material heading our way. Coronal mass ejections, big blobs of charged gas flung off the sun. These 2 are faint, and they're only likely to give Earth a glancing blow over the next day or so.
Glancing, but not nothing.
Not nothing. Layer those CMEs on top of a fast stream already flowing from a coronal hole, a gap in the sun's outer atmosphere, and the models suggest we could tip into a G1 storm. That's the mildest rung on the scale. No drama for the power grid, but enough to nudge the aurora to slightly lower latitudes than usual. Though over the coming nights, it's worth a look if you're up high, and I'll give you the where and when in the Skywatch. Here's the thread, though. That same solar wind, the constant outflow from the sun, is gentle at Earth because we've got a strong magnetic field and a thick atmosphere shrugging it off. Auroras are the pretty side of that shrug, but not every world is so lucky. Some planets have been standing in that wind for billions of years with no shield at all.
Which is the perfect cue for my next one. Meet Escapade, a pair of NASA's craft nicknamed Blue and Gold after the University of California, Berkeley colors, built by Rocket Lab and launched last November on a Blue Origin New Glenn. They're Mars-bound, and right now they're loitering out near a spot called L2, about 1 million miles beyond Earth, waiting for the road to Mars to open. While they wait, one of them turned its cameras back toward home and snapped a family portrait, Earth and the Moon together as two slim crescents. In ordinary visible light, they look exactly as you'd hope, two bright sunlit sickles against the black. But these cameras also see in thermal infrared, heat, and that view is stranger and honestly a bit beautiful. The night side of Earth glows softly with its own warmth, while the Moon's dark half sits far, far colder. A portrait in light and a portrait in heat of the same two worlds.
Gorgeous. But that's not why they built it, is it?
It's not, and here's where our thread lands. Escapade exists to study exactly what we were just talking about. Its whole job, once it reaches Mars in 2027, is to measure how the solar wind strips away the Martian atmosphere. Mars doesn't have a global magnetic shield like ours, so the same wind that just gives us auroras has over billions of years helped peel Mars from a warmer, wetter world into the thin, cold desert we see today. Two spacecraft, taking readings from two vantage points at once, watching a planet lose its air in real time. That Earth and Moon portrait was really a calibration check, a chance to point the cameras at familiar targets before the main event. But it doubles as a quiet reminder. A shielded world and an unshielded one are separated by not very much at all.
The wind that paints our sky and the wind that scours Mars. Same sun. Lovely thread, Avery. Right, out under the sky. First, the Moon. We've just come off the full buck moon on the 29th, so we're in a bright, waning-gibbous stretch. Beautiful to look at, but that glare will wash out anything faint for the next several nights. Worth knowing before you plan. Meteors, the southern Delta Aquariids and the Alpha Capricornids have just passed their peak on the 30th into the 31st. From here in the southern hemisphere, the Delta Aquariids still favor us, but with the moon this bright, keep expectations modest and watch for the occasional slow, bright Capricornid fireball, which both hemispheres can catch. The better news is what's coming. The Perseids build to their peak on the night of the 12th into the 13th of August. And this year, the moon is nearly new, so it's a genuinely dark, generous window. For North America, that's prime. Find a dark spot, look up after midnight, and the northern sky can deliver a meteor a minute at its best. From the southern hemisphere, the Perseids sit low in the north, so you'll see fewer, but a clear northern horizon is worth a try. Mark the 12th. Also on the 12th of August, a total solar eclipse. The path of totality runs across Greenland, Iceland, and a slice of Spain, with partial phases for parts of northern North America and Europe. If you're anywhere near it, never look at the partial sun without certified eclipse glasses that meet the ISO 12312-2 standard. Ordinary sunglasses will not protect your eyes. Totality only is safe to view with the naked eye, and only for those precious seconds it lasts. Planets, quickly, both hemispheres. The pre-dawn sky is the place to be, with the brighter planets gathering low in the east before sunrise. From Sydney, look to the eastern horizon in the hour before dawn. From North America, the same window, an hour or so before your local sunrise. One quick diary item, and this one's for our telescope owners. On the 5th of August, a dead SpaceX Falcon 9 upper stage, space junk we tracked since it launched Firefly's Blue Ghost lander back in January of last year, is expected to smack into the moon near Einstein Crater at about 6:30 Universal Time. For North America, that's the small hours of the 5th, and you're the best placed to try for it. Aim for the faint dust plume near the moon's eastern edge, not a naked eye flash. You'll want a decent telescope. From Sydney, the moon isn't up at impact, so down here we'll be leaning on the after images from orbiters like NASA's Lunar Reconnaissance Orbiter. And to close our thread, the aurora. If those solar storms land as forecast, watch the high latitudes over the coming nights, across the northern tier of the United States and up into Canada in the north, and down towards Tasmania, southern New Zealand, and southern Victoria in the south. Same sun, same wind, both ends of the Earth. And if you catch a glow, you'll know exactly what you're looking at.
Everything we talked about today, the links, the images of Nysa, and that Earth and Moon portrait is at astronomydaily.io, along with the daily newsfeed and the newsletter sign-up.
And if you spotted an aurora or bagged a Perseid, tell us. There's a listener contact form on the site, and we love hearing what you've seen.
That's Astronomy Daily for Friday, the 31st of July. I'm Avery.
And I'm Anna. Until next time, clear skies.